Hi, I'm Jesse with Mastercam, and in this video I want to show you some of the new and existing functionality inside of 2D chaining for toolpaths like dynamic, pocket, and area mill. Specifically, I will be showing how in Mastercam 2020 we now have support for air regions with more than one open edge. To make things as clear as possible, I'd like to highlight the face that I'll be programming. It's not required for this operation, but I find it useful to better organize, process, and visualize my part. To do this, I go to the Model Prep tab, and under the Color group, I select the Change Face function. I click on the face I want to change, and then pick a color. In this case, I want to use this light blue. When I'm satisfied with my selection, I click OK. Other than the color of this face, this makes no changes to the geometry itself or how I'm going to toolpath the part. On the Toolpaths tab, I select Dynamic Mill from the 2D toolpaths. I want to pick the machining region first, so I make sure I'm in solid selection mode, and I choose Face as the method. Then I select the face that we highlighted earlier. For this operation, I'm going to use the Stay Inside strategy. Using Stay Inside keeps all the toolpath motion inside the area we chained. This strategy is useful for machining pockets or times where a wall or boss is right next to the area we need to machine. To help visualize how Mastercam will process the chaining options I've chosen, I can use Preview Chains. When I launch Preview Chains, Mastercam temporarily color codes the area that will be affected by my toolpath. Other than the one wall next to our machining region, the other sides of our chain are open, so I want to tell the toolpath that it's free to use some of the space to enter and exit the material as needed. To do this, I'm going to specify air regions. Starting in Mastercam 2020, we now have the option to select multiple air regions when chaining, and the feature on this part is a great candidate for this. To add air regions, I click the selection arrow to the right of air regions. In this case, I'm going to use the Edges command in solid selection mode. I click on the first entity, then I'll continue along that chain using the next arrow. Once I've got my desired chain, I click End Chain, and then I repeat the process with the second open edge that I want to use as an air region. Once these air regions have been specified, I can use Preview Chains to see how they are going to affect the toolpath that Mastercam creates. As we can see, the preview looks different this time. The machining region is still being shown in red and black, but now the air regions that we selected are shown in blue. The yellow line around the outside shows the containment boundary, which is the border that the tool will not move beyond. If I want to customize these colors, I can easily do that by clicking the Color button next to Preview Chains in the Chain Options dialog. Now, when Mastercam calculates the toolpath, it's aware of the area to be cut, where it's allowed to move freely outside the material, as well as where it needs to avoid moving. And thanks to Preview Chains, I understand exactly how Mastercam is going to calculate the toolpath before I take the time to generate it, which lets me be more efficient and have greater confidence when working. Hi, I'm Jesse with Mastercam, and today I want to show you some of the new enhancements in chaining for Mastercam 2020. The part I'm working on is an aerospace cabin door latch assembly. Due to the way this part was processed, we have a separate solid base that was created to support the part during machining. Many times, when machining a part with complex fixturing, it's necessary to program operations that will machine more than one body at a time. I'm going to start by creating a simple contour operation by going to the Toolpath tab and launching Contour from the 2D Toolpath gallery. This will open the new Chaining Manager, which has been completely revamped for Mastercam 2020, to make it easier to use and to accommodate the new functions that have been added. Let's start with the partial chains by clicking the Partial Loop button. When prompted, I'll select this edge on the part. Once the face is highlighted, the next step is to verify that Mastercam selected the correct face by clicking the green check, followed by the entity that I want the chain to end on. Once I select the final entity, I can see a visual preview of the chain I selected. For this operation, I'd also like to cut a contour against the base structure. In past versions of Mastercam, I would have to click Apply or relaunch the chaining dialog but in Mastercam 2020, I can do this in the same chaining session by simply clicking the next edge I want to chain. In this case, I only want to select a single entity, so after I verify the face Mastercam selected, I can re-click the entity to end the chain. If needed, I can change the chaining direction of the entity by clicking the reverse arrow. Let's take a quick look at what the contour operation looks like by clicking the green check to close the chaining manager, and then clicking the green check to save the 2D contour operation. After the toolpath has generated, I can add more entities to this operation by clicking where it says Geometry under the contour toolpath in the Operations Manager. This will launch the chaining manager. To add more chains, I'll right-click and choose Add, which will relaunch the chaining dialog. Instead of using partial chain, I'm going to select Edges. If I want to select one internal edge and have Mastercam automatically select all tangent edges for me, I can simply hold down the Shift key while I select my first edge. Another enhancement in Mastercam 2020 is that I can also select a separate disconnected edge and then use the Next button to continue around any connected edges to create the selection I need. These are only a few of the chaining enhancements that are available in Mastercam 2020. I hope you find these as useful and time-saving as I do. Hi, I'm Jesse with Mastercam, and in this video I'd like to talk to you about stock models. When programming a complex part, I make sure the first operation in the toolpath manager is a stock model. I'm able to reference it for programming in future operations, and it makes it easy to visualize the raw stock when planning my workflow. To create a stock model, I go to the Toolpaths tab and click on Stock Model. The first thing I need to do is give it a name. In this case, I'm just going to call it Stock. I'm also going to pick a custom color for the stock model so I can differentiate it from future stock models I plan to use in this part. In this case, I'll use color 124. I then need to define the initial stock shape. For this, I'll pick the predefined solid body on level 99 in this file. I can then click OK and the stock model is automatically generated and displayed in the graphics window. If I want to show or hide the stock model, I can easily do so by clicking on Toggle Display on Selected Operations in the Toolpath Manager or by pressing the T key on my keyboard. This is the same way I would show or hide the display of a toolpath. Being able to toggle my stock model this easily means that I don't have to go back into stock setup in my machine group properties or even turn on and off a level in my levels manager. This means I can work faster and more efficiently. Now that the stock is set up, I'm ready to create my first operation. For my initial roughing operation, I'm going to go to the Toolpath tab and select OptiRough from the 3D toolpaths. For my machining surfaces, I'm going to select the entire part. I could do this by window selecting, but there's another method available in Mastercam. If the part is complex, or there's a lot of geometry on screen that I don't want to accidentally pick when window selecting, I can simply click 3 times on the solid body I want to pick, and the entire body is automatically selected. Back on the machining geometry page, I'm going to enter stock to leave values for my walls and floor. If I want my toolpath to avoid my vise, I can use the avoidance geometry controls and select my vise. This time, I'll window select the bodies that make up the fixturing and end my selection to return to the toolpath parameters. On the tool page, I'm going to select the 12mm bullnose end mill I have in my library. The holder has already been defined for this tool, so I don't need to make any changes on the holder page. Next, we'll go to the stock page and choose one other operation as the rest material type, then select the stock model operation we created earlier. To most efficiently cut with any of the dynamic motion toolpaths for milling, it's best to use a small step over with a much larger step down. The step down allows us to utilize as much of the cutting length of the tool as possible, and the small step over means we can cut at much higher speeds. This will reduce cycle times and make our tools last longer. On the cut parameters page, I'll set a 25% step over and a 200% step down. Next, we'll go to the Steep Shallow page to look at another new feature for Mastercam 2020, Adjust for Stock to Leave. This new option makes the Steep Shallow page aware of the floor stock you entered on the model geometry page. This means that in a situation where I want to select a point for my maximum depth, I don't need to remember to manually add or remove my stock to leave amount from the selection I just made. Instead, Mastercam will automatically apply the stock to leave value I entered on the model geometry page to my minimum depth for me. For my minimum and maximum depth values, I'm going to leave the minimum set to Z0, and for the maximum value, I'm going to right-click in the field and select Z coordinate of a point. Since I want to cut all the way down to this flat surface, I'll select an appropriate auto cursor position. Thanks to Adjust for Stock to Leave, Mastercam takes the Z value of the point I just selected and automatically subtracts the correct amount of stock to leave. Now I can click OK to close the toolpath parameters page, and I can review the toolpath. By having my initial stock setup represented as a stock model, it gives me a great visual representation which helps me when I'm thinking about how to program the part. I'm also able to use it as rest material for my roughing operations, and I can use it as the stock definition in simulation. And since I can easily turn on and off its display, just like any other operation in the Toolpaths Manager, it's always there when I want to reference it and hidden when I don't. Hi, I'm Jesse with Mastercam. In this video, I want to show you some of the changes that have been made to Holemaking in Mastercam 2020. In previous versions of Mastercam, programming multi-axis drilling and circle milling operations was done in a different interface than 2D drilling and circle milling. Starting in Mastercam 2020, the multi-axis and 2D interfaces have been combined. Here we have a 3-axis drilling operation that's center drilling 3 separate holes. Due to machine and travel limitations, I know that I'm going to need to drill this topmost hole from the other side of the part. Before Mastercam 2020, this would mean creating another toolpath with a different tool plane on the backside of the part, or deleting this toolpath completely and creating a new 5-axis toolpath instead. With the consolidations that have been made to the Holemaking interfaces, I can now easily convert this drilling operation into a multi-axis operation by going to the Tool Axis Control page and selecting 5-axis. On the Planes page, I want to make sure that my WCS, tool, and construction planes are all set to top. Now all I need to do is tell the toolpath which direction to drill the holes from. In 3-axis, the direction that Mastercam drills the holes from is controlled by the tool plane that's selected. But now that I've changed this to a 5-axis toolpath, I need to tell Mastercam what direction to drill the holes from. To do this, I need to go to the Toolpath Type page and relaunch the selection dialog. Each of my selected holes now displays a green arrow which clearly shows me which direction the holes will be drilled from. To change the direction, all I have to do is click the green arrow. Now let's regenerate the toolpath and take a look at it in Backplot. The 3 holes are being drilled from the directions that I need, but there is one issue. When the tool moves from the first hole to the second hole, it's moving directly from one point to the next, gouging the part. This would cause a crash at the machine if we were to try and run this code. This is a perfect example that shows you why you should always review your toolpaths in Backplot or simulation before posting them out. For this toolpath, what we want to do is retract to a safe distance, reposition, and then drill the next hole. To do this, I need to reopen the toolpath parameters, and under linking parameters, I need to make some changes to the safety zone page. If you're new to multi-axis programming, a safety zone is an area you can specify where Mastercam will not perform any linking moves. Instead, the tool will retract out past the edge of the safety zone, and only then will the linking move reposition the tool for the next cut. Once safety zone is turned on, I can click Define Shape, and in the graphics window, I'm going to select the part itself. I could also select my vise or any fixturing if I wanted to, but for this operation, it isn't needed. The safety zone is displayed around my part, and I can click on any of the faces to adjust them as needed. This is very similar to using the bounding box feature in Mastercam. which you may be familiar with. Let's save these changes, regenerate the toolpath, and take another look at it in Backplot. With just a few additional settings in the exact same interface, we were able to easily convert a 3-axis drilling operation into a multi-axis operation that drills the holes from the sides we need, safely links between the two sides of the part, and is ready to start making chips. Hi, I'm Jesse with Mastercam, and in this video I want to show you the advanced toolpath display functionality in Mastercam 2020. In this example, we have a pair of 3+2 dynamic OptiRest operations that are roughing both sides of this part. For now, we're going to focus on only one toolpath, so I'll turn off the display of the other toolpath by selecting it and hitting the T key on my keyboard. To access Advanced Toolpath Display, I'll go to the View tab and click on the Advanced Display under the Toolpaths group. In the graphics view, Mastercam is now displaying the microlift repositioning moves in brown and the toolpath feed moves in blue. Let's concentrate on just the feed motion for now. To do this, I can turn off the display of any motion I don't want to see, such as entries, exits, and rapid motion. Now we have a clutter-free example of just the feed portion of our toolpath. Let's turn off the Advanced Toolpath Display and look at a real-world application of this function and how it can be leveraged to get some visual feedback on how the G-code is going to look. To do this, let's open the parameters of the first OptiRest operation and look at the arc filter tolerance parameters. Notice I have a fairly loose 0.05mm total tolerance and my arc filter is turned on. Now let's compare these settings to those of the next OptiRest toolpath. I have a much tighter tolerance here and no line arc filtering is turned on. It's important to understand that there's no right or wrong when it comes to the settings on the arc filter page. These settings depend completely on your process, the machine you're cutting on, and what your machine's controller wants to see. Mastercam gives you the flexibility to tailor the code to your specific needs. Since we know that the tolerance settings for these two toolpaths are very different, let's look at the toolpath motion in the graphics window. You'll notice that if I turn on both toolpaths, I have no way of knowing that they are using different arc filter settings, since they look identical. That's because we're still looking at only the feed motion. If we want to get a better picture of how the G-code is going to be output, we just need to go back into the Advanced Toolpath Display and turn on endpoints. Now, each line of G-code is represented by the segment between each endpoint. If I want, I can also change the color and options that Advanced Toolpath Display uses, and my changes will be visible in the graphics window as I make them. Now that we have these endpoints displayed, we can start to get a feel for how much code we will have when posting out. If we look at the second toolpath, we can see that it's broken up into much smaller segments. Remember, this is the toolpath that was using a tighter tolerance and had arc filtering turned off. Tolerance and arc filter settings have a massive effect on toolpath output and calculation. By turning off the arc filter and tightening up my tolerances, I'm giving the machine far more code to handle. Thanks to Advanced Toolpath Display, I can examine these differences in a quick, easy, and visual way without having to post the code. Hi, I'm Jesse with Mastercam, and today I'd like to show you some of the guided chaining options in Mastercam. Let's look at this aerospace cabin door latch part and investigate some ways that the new chaining dialog can cut down on wireframe creation when creating toolpaths. First, I want to create a contour operation that will cut the entire outside silhouette boundary of the shape. I do this by going to the Toolpaths tab and selecting 2D Contour from the 2D Toolpath gallery. This launches the new chaining dialog for Mastercam 2020. Two geometry selection modes are located at the top of the dialog, wireframe and solids. For this operation, I'm going to select directly off the solid model, so I use the edges function, which is the top left icon. Mastercam will prompt me to select an edge, so I'll click on the first entity of what will become my chain. Once I've started my selection, 3 arrows will appear. The start of the chain is shown in green, red indicates the default direction for the chain, and the blue arrow shows the alternate branch. I can advance the chain in 2 ways, either by hitting the next button in the chaining dialog or by clicking the arrow that highlights the route I want to follow. As I advance around the part, there may be areas where Mastercam follows a different route than I need. I can back up by clicking the previous button, which is new to Mastercam 2020. Clicking previous will back my selection up by 1 edge and leave the rest of my selected chain in place. When I'm back to the proper branch location, I can either click the blue arrow or click the adjust button. The edges chaining method allows me the freedom to be creative in how I create my chains. For instance, I can adjust the chain to go back to the other side of the part. Once adjusted, I can continue to advance around the part either by clicking the arrow I want to follow or by using the functions in the chaining dialog. When I'm satisfied with my selection, I can click OK to close the chaining dialog, which will then launch the contour toolpath. When you've selected a complex chain that has varying depth, Mastercam will set the contour type to 3D by default. However, I'm machining the silhouette boundary of the part, so I need to make sure that the toolpath that's generated is a 2D contour. On the cut parameters page, I set the contour type dropdown to 2D, then go to the linking parameters page and set the depth to Z0. After this, I can set the top of stock by clicking the top of stock button and selecting an appropriate auto cursor position on the model. Next, I can click OK and let Mastercam generate the toolpath. Once I inspect the toolpath and am satisfied with the result, I can launch machine simulation to view the toolpath in motion. Hi, I'm Jesse with Mastercam. In this video, I want to show you some enhancements that have been made to drilling, which improve selection and visualization of your drilling operations. For this example, I'm going to be drilling a few holes in this aerospace latch assembly. On the Toolpath tab, I'll launch Drill, which will bring up the Toolpath Hole Definition dialog. I can select the solid face inside each of the bores, and Mastercam will automatically determine the hole axis and create the drilling positions. Once my holes have been selected, each hole is listed under Features, and some basic information is displayed about the geometry type of each hole and its diameter. Additionally, each hole is marked with a green arrow in the graphics window, which indicates which side of the hole the tool will enter from. If I was creating a simple 3-axis drilling operation, these arrows would have no effect on the toolpath, since the direction the holes are drilled from is controlled by the tool plane that is set in the toolpath parameters. However, I'm going to create a multi-axis drilling operation, so I need to make sure these arrows are pointing in the correct directions. I can change the direction of any of these arrows by simply clicking on them. Having all this information readily available, as well as being able to control my hole axis direction so easily, is a game changer when I'm programming a part with hundreds of holes in it. Once I'm satisfied with my selection, I can close the Toolpath Hole Definition dialog, which will automatically launch the drilling parameters. On the tool page, I'm going to select a 3mm drill so that I can pilot drill each of the holes before bringing them to a final dimension in a later operation. On the Cut Parameters page, I'll select Peck Drill from the Cycle drop-down list. I'll set 3mm for the first peck distance, followed by 1mm for the subsequent pecks. On the Tool Axis Control page, I'll set the output format to 5-axis, since the holes need to be drilled from more than one plane. Since I took the time to set the drilling direction for each of my holes when I selected them, I already know what to expect when I select 5-axis as the output format. If this were a 3-axis drilling operation that I wanted to convert to a 5-axis operation, I would want to make sure to review my geometry selections to make sure my drilling directions were correct. On the Linking Parameters page, there are 2 new checkboxes. At the top of the dialog, there's Calculate Incremental Values from Holes and Lines. What this means is that the incremental values for clearance and retract are measured from the top of the hole geometry, while the depth is measured from the bottom of the hole geometry. At the bottom of the dialog, there's Calculate Depth from Top of Line or Hole. This checkbox lets us override where the depth value is calculated from. With this checked, the incremental value is now measured from the top of the hole instead of the bottom, which is very helpful for things like spot drilling multiple holes of varying depths at the same time. With these checkboxes set, I'll enter a depth of 20 millimeters and click OK to close the toolpath dialog. When the toolpath is done generating, I can launch Backplot. Prior to Mastercam 2020, there was no visible difference between a standard drilling operation and a PEC drilling operation when you reviewed them in Backplot. Starting in Mastercam 2020, each PEC of the drilling cycle is now simulated. By pressing the S and B keys on my keyboard, I can step forwards and backwards through Backplot, allowing me to take a closer look at individual moves or motions.